Hello everyone, today we are going to be talking about factoring. Specifically, we're going to talk about a method called factoring with GCF. Now, we haven't talked about factoring quite yet, but this is going to be the first lesson of several that deal with factoring. And so we're going to start by kind of looking at this idea of a GCF and how that helps us in this concept of factoring. So we'll get to the factoring part. We're going to start with just the GCF piece here first. So GCF is a concept that you learned really a while ago. But it stands for the greatest common factor. Greatest common factor. And that name is actually very descriptive. It pretty much tells us what the definition is. The greatest part means it's the largest value. Okay, and it's the largest value that factors. So we're using that kind of factor word, and that factors means that we can multiply into all, I'm going to say terms, but you could say values here as well. Okay, and the fact that it goes into all of them means it's common. Okay, because lots of these things that we're going to be working with have multiple factors, and they can at times have very large factors, but we want the largest one that goes into all of them. So let's start with kind of breaking down just numbers, and then we'll worry about what that looks like when we get numbers and variables and everything else going on. So if we start here with some numbers, if we start with 20 and 50, what we really need to do is we need to list out all of the factors that go into each of these. Okay, so I have 20 and I have 50. Now a factor is anything that can multiply by another number to give us the number that we want. So for 20, it's anything that multiplies by another whole number. I should specify it does have to be whole numbers. We can't use decimals or fractions here. So it's another whole number that multiplies together to get 20. Now these typically we say come in pairs because you need two things to multiply. So for example, I have 1 and I have 20. And I'm going to separate them like this because we're going to make a list here. And I'm going to try and make the list go in order. So after 1 would be 2. 2 goes into 20, and it's 2 times 10. I can try 3, but 3 won't work. 3 doesn't go into 20 evenly, but 4 does, and it goes with 5. Now at this point, I'm to the list kind of coming down, and they meet in the middle, so I know that this is going to be all of my factors. Okay, we can do the same thing for 50. I know I'm going to have 1 and 50. 2 will work with 25. Then I have, let's see, 3 won't work, 4 won't work, 5 looks like it will work. And that goes with 10. And there's still quite a bit of a gap here, so I need to check the others. 6 won't work, 7 won't work, 8 and 9 also will not work. So then I'm to the 10, so I know that this is my list of everything. So then my common factor, or my greatest common factor, is this 10 here. So my answer for the GCF for 1A would simply be 10, because that's the largest number that I have in both lists. Okay, let's try something else with B here. B, I have 55 and 75. So we'll start with 55. I get 1 and 55. 2 won't work, 3 won't work, 4 won't work, 5 will work with an 11. And you can keep going and check the rest, but that's actually the only other one that's going to work. 75 gets a few more. We get 1 and 75. We get 3 and 25. We get 5 and 15. Also work. And let me just quickly show you here. If you have a calculator, I'm doing these just because I know these numbers and I can come up with those factors. If you need help doing that, on your calculator, if I wanted to find the factors of 75, I would just start dividing. Dividing by 1, we know we're going to get 75, but if I divide by 2, get a decimal, doesn't work. So I do 75 divided by 3, gives me a whole number, so I know both the 3 and the 25 are factors. Okay, you can do the same thing, divide by 4, decimal doesn't work, 75 divided by 5, there's my 5 and 15. You can keep going, 75 divided by 6 is a decimal, 75 divided by 7 is a decimal, 75 divided by 8 is a decimal, and you can just keep going all the way through here and see that all of these are going to be decimals until I get back to the 15, which I already know goes with the 5. So I'm done when I get to that point. Okay, common factor here, greatest common factor is going to be the 5 then. So my greatest common factor is 5. Okay, let's do it with a group of 3 numbers. Now this one I'm going to do slightly differently as well, just to show you another method that you could also use to find your greatest common factor. So we're going to go back to a concept that we used earlier in the year called factor trees. So I'm going to take 12 and I'm going to split it into a factor tree. Okay, to do that I'm looking for things that multiply to give me 12. Okay, so I'm going to use 4 and 3 because then I can split the 4 into 2 and 2. Okay, let's try 48. I can split into, let's say 4 and 12. 4 splits to 2 and 2. 12 is 3 and 4. 4 splits to 2 and 2. 60, we can split, we'll just go 6 and 10, which is a 2 and a 3, and 10 is a 2 and a 5. Now what I'm looking for is I'm looking for how many common pieces I can find in all of these. So I'm going to start, I have a 2, and I can get at least one 2 out of every list. I can actually get a second 2 as well. Okay, I have that in every list. I also have a 3 at the end here in every list. I'm looking specifically at the end of all of these. And that's all I get from the 12, so I'm not going to be able to get anything else out of that. I have these extra 2s here, but they don't come from anything else. Same thing with the 5. I can't match them with anything. So what I have here is I have 2 2s and a 3. If I multiply those all together, 2 times 2 is 4, times 3 is 12. So my greatest common factor is 12. Okay, so that's nice when you have maybe some bigger numbers that it's harder to list out all of the factors. You can see where these lists might get very long, especially for something like 48 has a ton of factors. So might be easier to kind of go this route. The other thing you can always test is take the smaller of the numbers and see if it goes into the other ones. So like 12 divides evenly into 48 and 60. So that's going to be your greatest common factor because that's the greatest factor that 12 has. 12 won't have anything bigger than itself. So you can always check that one as well. Just some other things to look at. Let's talk about if they're termed. So now I have numbers, but I also have these variables that go with them. So if I look at the first one here, I'm going to split these into two things. I'm going to split these into numbers, and I'm going to split these into variables. So for my numbers, I'm looking for the greatest common factor between a 25 and a 75. Well, if I use the trick that I just said, does 25 go into 75? It does. So my greatest common factor is going to have to be a 25. Then if I go to my variables, this is the new part here. I have an x to the third and I have an x. Well, if I think about this, x to the third is the same thing as x times x times x. X is simply just x. So if I look at what I have in common, I have one of those x's, so I just have an x. And my final answer then is going to be 25x is my greatest common factor. Okay, let's try that again with another one, just because the more of these that we do, the more that's going to make sense. We'll do numbers, we'll do variables. Okay, numbers for the first one here. I have 9 and, part B here. I have 9 and 21. Now, I'm not going to make the list of these ones because what I want you to do is just start to get in a habit of trying to figure out what that number is. Well, if I try 9, 9 doesn't go into 21. So let's think about what we do know goes into 21 and into 9. Well, 3 definitely goes into 9, and 3 also goes into 21. And I think that's going to be the only thing they have in common. So I'm going to use a 3. For your x's, I'm just going to pull these out separately here. I have x to the fourth, and I have an x to the third. Well, if I think about how many I'm going to have in common here, this is going to be 6x's all multiplied. This is 3x's all multiplied. So the most I'm going to be able to pull out that's in common is going to be an x to the third. And do the same thing with the y's. I have a y to the fourth and a y to the third. The largest I'm going to be able to pull out is another y to the third. So my answer here is going to be 3x to the third, y to the third. Okay, now, the point of doing this with these is to start to figure out what these greatest common factors are, because they're going to help us as we get to the factoring piece that's on the back of this. So what I want you to do is look for the patterns that we have here. The numbers, you really just kind of got to figure out what's the biggest number that goes in. But for the variables, if you look, what I'm pulling out here in both of these two, and you'll see it in the next one as well, is the smallest exponent that I have on that given variable. So if you look at the first one here, the smallest exponent I had was a 1 or just an x. So that's what I was able to pull out as my GCF. Same thing in B. My smallest exponent on x was a 3. My smallest exponent on y was a 3. So I pulled out an x to the third and a y to the third. That's always going to be your kind of rule that you want to follow for your exponents. What's the smallest exponent that I have in everything? Okay, so let's go to C here. We'll start with our numbers. I got an 8, a 20, and a 16. I'm just looking at those. Those are all multiples of 4. So I think 4 is going to be my one that comes out of that. I could try 8, but 8 won't go into 20. So we'll just pull out the 4. So for numbers, we're going to get that 4. For variables, if I look here, I have an x to the ninth and an x to the fourth. So the smallest exponent that I see is an x to the fourth, but I don't actually have an x in this last term, which is an issue because I need to be able to pull it out of everything. It's the greatest common factor. It needs to be in everything. So if I think about what x's are here, well, if it's not showing up, it must be an x to the 0, which means the largest thing, or the smallest exponent I have is actually 0, so I don't have any. So really, I don't have any variables that I can pull out there. So I'm just going to say none, and my greatest common factor here is simply a 4. Okay? I wouldn't be able to pull out any variables in that one. Okay? And that's good to just know that that's an option. Okay? Sometimes those variables won't come out. Sometimes the numbers won't come out either. Sometimes I might give you a number that just doesn't fit the pattern, and you just don't get a number that comes out of it. And we'll talk about what that looks like in terms of the factoring here in just a second. So on the back page here, let's actually talk about what factoring means. So factoring is going to be, again, something that we talk about over the next several lessons. This is going to be finding out, or finding, sorry, what to multiply to get an expression. Okay, I always kind of think of this in my head as it's unmultiplying. Okay, so it's kind of the opposite of multiplying. And I know we think of division as the opposite of multiplying. You'll see there is going to be some division involved in this, but we're really trying to get back to before we multiplied. So what pieces were we actually multiplying together? Okay. Now it is possible when we start to get into these polynomials that some of them cannot be factored. If that happens, we call them prime, just like we have prime numbers. Prime numbers cannot be factored other than one in themselves. We use that same term for polynomials. So just know that's an option. We don't technically have any in your notes here. Maybe when we get to the end, I'll make one up just so you can see what one might look like. Okay. Let's get to example 3 here though. So I'm trying to factor each polynomial using a GCF. So before I even get into actually trying to factor this, I'm going to try and find my GCF first. And what I'm finding is the GCF between the terms. So the same thing that we are just doing in example 2, just separated with commas, is now separated with a plus. And so I'm going to use that as my GCF. So if I go ahead and look here, I have a 4 and an 8. Definitely 4 will go into 8. So my number that I'm going to get as part of my GCF, and I'm just going to list out my GCF here, is going to be a 4. As far as my x's, I have an x to the third and just an x. So the smallest exponent I have is going to be the x to the first here, or just x. So I'm going to pull out a 4x. And when I say that, I say I'm pulling out a 4x. That means I'm undistributing it from this 8x to the third plus 4x. So my 4x is going to be what's out front, and I'm going to be left with this thing inside the parentheses here that if I wanted to keep going, I could distribute through and get back to this 8x to the third plus 4x. I can multiply it to get back to. So I have the 4x out front. So what you can do, and this is where that division comes in, is you can think of dividing each of these by a 4x. Well, if I take 8 and divide it by 4, I get a 2. And if I have x to the third and I divide by an x, I subtract the 1 away, and I'm left with just simply x squared. Do the same thing on the last one here. The 4's will cancel and the x's will cancel. I do have to include a 1 there just to hold the place. Otherwise, if that's not there, I'm only going to get one term when I multiply. I need to get the 2 terms that I have here. So this here actually is my answer. Hey, that's all you need to give me, but just for the sake of notes, I want to show you what we did here. What we did is we figured out what do I need to multiply together to get back to this, which means I should be able to FOIL this now, or multiply it, and get back to where we started. So let's try it real quick. If I do 4x times 2x squared, I get an 8 with an x to the third, and a 4x times 1 is just a 4x. Okay, so this here is kind of like your check. Okay, that it does multiply and get us back to where we started. Okay, you do not need to do that on all of your homework questions, but if you get one where you're just not quite sure if it's going to work, try it. Okay, and give it a shot. Multiply it out, see if you can make it work. Let's go to number 4 here. So this one we're starting to get more variables, bigger numbers, that sort of thing that we need to start to figure out. So let's see if we can figure out our GCF first. If I start with the numbers, I get a 25 and a negative 35. Just looking at those, they both end in 5s, so I think 5 is probably my GCF. Again, you can go through and start dividing things out and see what those are. Quick note here, as far as negatives, I typically take whatever the sign is on the first term. So if the first term is positive, I'm going to take a positive. If my negative was on the 25, I would probably pull out a negative. Okay, now that's completely optional. If you want to always pull out a positive and just leave it as positive, that's fine. It's really your choice. So again, I'm going to make that a 5. Next, I need to look at p's. So p's, I have p to the 4th and a p to the 7th. Well, the smaller of those two is p to the 4th, so I'm going to use that one. For q's, I have q to the 8th and q to the 6th. So q to the 6th is the one that I want. So what I'm going to do is I'm going to pull out a 5p to the 4th q to the 6th, which means then that's the piece that I'm dividing by. P to the 4th q to the 6th and 5p to the 4th q to the 6th. Okay. Now, when I do that, the 5 will divide the 25, which leaves me with a 5 as well. 4 divided by 4 on the p's is going to cancel. Q to the 8th divided by q to the 6th, I subtract these exponents. 8 minus 6 is 2, so I'm going to get a q to the 2nd. For my second one, I have negative 35 divided by 5 is negative 7. Don't forget your negative there. P's, I get a 7 minus 4, which is 3. And Q's is 6 minus 6, which is 0, or those go away. So I'm going to close my parenthesis here, and that is my answer. Again, you could multiply that out and make sure it works. For the sake of time, let's move to number 5. Okay, with number 5 here, I am again looking for my greatest common factor, GCF. So I have a 12, a 16, and an 18. They are all even, so I know 2 will go into them at least. 4 possibly could, but that doesn't go into 18. 6 goes into 12 and 8, but not 16. So I think 2 is probably my best bet. Looking at R's, I have an R to the 9th, an R to the 5th, and just R, or R to the 1st, so that's the only one I can take. For S's, I have 1 in the first, 5 in the last, but I don't have any in the middle here, so I'm not allowed to put any S's in my GCF. So my GCF is just going to be 2R. I'm going to put that out front. And then in parentheses, I got to divide by 2R. So when I divide by 2 on the 12, I get a 6. When I divide by R, that's going to drop the exponent by 1, so it brings it to an 8. And then S comes down as well. Because I didn't have any S's, it just moves down. 16 I divide by 2 is 8. R drops by 1, so it goes to R to the 4th, and then there weren't any S's there. And then negative 18 is going to give me a negative 9. R goes away, and I end up with an S to the 5th because it just drops down. Okay. Couple things as far as answers here. I'm just trying to think of the common mistakes that I see a lot. This piece that I'm dividing by is your GCF. That needs to show up as part of your answer in front of what you get after you divide. Do not give me just the answer that's in parentheses. You will lose points for that. Okay. You also need to make sure that you have that GCF out front as well as everything that's now simplified after you've pulled that out in the parentheses. Don't give me the original thing again. Okay. The other thing, I just want to give you an example of what we put up here where it's prime. Let me give you, we'll call this number 6. Let's say I give you 17x to the 4th plus 5y to the 3rd. Okay, and if you just look at that, you can start to see that there's not a lot I'm going to be able to do. 17 is a prime number, which means the only thing I can pull out of it is a 1 and a 17. 5 is also prime, so it's only 1 and 5. If 1 is the only thing you can pull out, there's no need to do it because it's going to stay the same. As far as my variables, I have x's here and y's here. They're just not going to work. So there's no way to get anything out of this. So we're just going to simply say that it is prime. All right, and that ends up being your answer then is prime. The other option is you could just list out what you have from the start if you want to write it that way. Okay. All right, I think that is it for this video on factoring with GCF. If you have any questions, let me know, and we'll try and get those sorted out.